The last part is on writing a program a bit more advanced. Just to remind you, we are not trying to learn to be an expert programmer on assembly language. We just learn enough to understand a lot more things about programming and computer architecture in general. Okay, so my aim is to, for this last session, is to introduce you a bit more advanced thing like function call, right? And we will write a complete assembly language program. First, I will introduce you the assembly language. In a complete program, there are 3 sections. In the previous lecture, we already talked and show you how to write and convert the program to machine code and run it under simulator. What we have seen is just one section in the program. We call that the code section. The other 2 is a symbol section and data section. Symbol section just look like this. So when you write a complete program, you have 3 parts. The first is to define the symbol, okay? And you can use this symbol to denote the value. Then you will have the name for your value, which make it easier. And the code section, we already seen that. And to be able to set the value in the memory, we can use the data section like this. Okay, let's start with writing symbol section. Okay. Let's come back to the very easy first program. We want to write the program to perform A equal B plus C. Now that we know about the symbol, we can replace the name of the register by the name of variable. So we want register number 1, so to become a variable name A, so we write it this way. Then we can use this name instead of the number of register like this. So we can move B, C, and we can add A, B, C, so on. This makes things much easier. Okay. Let's try this program and see what it assemble. Output. Okay. Let's call this program symbol, right? Okay. And we assemble and see it. Check if the program is there. It's there. So we assemble that. And we want to see the result. Okay, so if you look at the first instruction, right, The B is register number 2, which appear here. And the C is register number 3, which is appear here. And then you can see this instruction, add A, B, C here. Okay, that show you how the symbol section works. It is very convenient for us not to remember the register name. However, you still have to allocate or assign the register by yourself. Okay. Next is the data section. Let's see how this simple statement do. We put this value into the memory beginning at the location here. Okay, let's assemble that and call it simply data. Okay, let's assemble it. First, see if we have that program. We do have it. Assemble it. And see the results. Okay. We don't see it here, so let's see the object code. Okay, in the object code, there's some value inside. We can run this program. There is no code, but it will set the value in the memory. Once it's loaded, we can dump the memory to see it's there. Okay, that is how we can predefine the value in the memory. Okay. With this, we can start to write a more what we call readable program. Let's say we want to do if then else like this. As usual, we start with assigning register. Okay, so we use symbol register A in register 1, B in register 2, and the flag in register 3. And then we write initialize the value with this one if A equals 0. Okay, so this is checking if A equals 0. We initialize A with this with 1 and initialize B with 0. And if it's not true, then we jump to the false action, which is let B become 2. And if it's true, then we let B become 1 and then jump up over to the exit, which we stop the program here. Okay, so let's use this program. And save as if x, okay, let's call that. Okay, see if we have the program there. We have it and assemble it. Check the result. It looks okay. Then run it. We will not go step by step, we go all at once, right? Boom, and see the result. Our program is A equal 1, therefore it is true. So B should be resolved in 1. Okay, you can see here. Let's change the program a little bit. Where is my program? Okay, if okay, here. Let's change A to 0. Now B should be 2. Okay, when we run this program, save it, type it out. You can see how tedious it becomes, but it is easy. Okay, assemble it, check the result. Okay, look okay, and run it. Go, and the register B. Okay, A equals 0, then B should be 1. Okay, right, the result is correct. Okay, that's how we write a more complete program. The next level up, we want to break one chunk of program into small function, which is a usual practice when we write program. In the language of assembly, we call function a subroutine, right? Or in high-level coding, we can call this practice what we call factoring. Okay, so we have the code, we factor code into very component which can be reused. That require abstraction of a function, or to our jargon today is called subroutine. So we want to do a call to a subroutine. When we jump to the subroutine, we need a way to come back where we call them, right? So we need a way to return. So we use a register to store return address. Okay, so in terms of instruction in our processor is called jump and link. Okay, we use one register to store the return address, and the address specify where to jump to. Let's see very simple code. Let's see if we have a main program that we want to double the value of register 1, and we make that into a subroutine or a function. This function has no parameter yet, so we all use a so-called global variable. Okay, so we jump from here to this section of program, and after it finishes, it returns to next instruction, which is the stop. So this simple program, we use the value in register 1 and we double the value of that register. R2 is storing the return address, and that is required when we want to execute the return instruction. So that there is jump and link and return. Let's try this code out step by step. Okay, let's save it. Call this one call, right? Save. Okay. Let's try it out. Do we have the right program? Seem okay. So we assemble it. Check if the result is correct. Look okay to me. So run it. Step by step. Okay. So the first line we encounter is the main program, which move value to register 1. Next is it will call to double. Okay, so the next instruction rather than trap, it should be the double. So at the location 3, so let's see where it is. Okay, so at the location 3 is the instruction add. Now the value has been doubled. See the value of register 2, which store the return address. When it returns, it has to be the next instruction after jump and link. So it will be this instruction. This instruction is at location 0. This is 1, this is 2. So the return address is 2. Right? So let's see whether it execute, return it, and then return back to true, which is the stop instruction. So this is how we call and return a function. Okay. However, when we make a function similar to this example, we need to be able to pass a parameter. Maybe we want to do double x, right? So how we send the value of x? In the previous example, x is stored in register 1. And we know that we are using register 1 between the main program and the subroutine. If we don't want to know that, we can send the value or the parameter of function using the stack. Okay, stack is a data structure, have 2 operations. Okay, in assembly language, it's push and pop. The value to be pushed is stored in register. Another register must be used because that is the pointer to the stack data structure. We call it stack pointer. Right? Okay. All the value to be calculated inside a processor need to be stored in a register. We have 32 of them, so we can designate 1 or 2 of them as a stack pointer. All right. Okay, let's see this sequence of code that perform stack operation. We need a stack pointer, so we assign register number 3 to it. And the first line, we have to say where our stack is. In this case, we put it at the location 100. And this is the value. Okay, and we push this value to that stack. Okay, and let's clear the value and then pop that value back and see the result. Okay, let's run this code. Call it stack, all right? I'm trying to write super small program so that you can follow it without difficulty. Okay, let's see. That's my, okay, it's there. Convert it. And check if we write the program correctly. It seems so. So we try to run it. Boom. And we run step by step. Okay. Let's see where the place where our stack is. It's still nothing there. The next instruction, we move some value and push it to the stack. Now, let's see the value there. Okay, so 1 value has been put onto the stack, right? And the stack pointer itself increment previously before it push is 100 and increment to 101. Okay, so it increment then store. And in the reverse, now we clear reserve 1, now become 0. And we pop the value from the stack back and the value come back here. You can see that the value in the stack there, but the stack pointer already decrease to the beginning. Okay, from 101 to 100. Okay, that's how we manipulate the stack data structure. Now, once we know about the stack, we can use it to pass the parameter. We rewrite our program to pass the parameter in the stack. With that, we don't have to know the function don't have to know what register the main program used. We just can find it in the stack. Okay. Now, look at the function. We return some value. In order to be able to know where the value is, you can also use stack, but it becomes a bit complex, right? In my case, I will just assign a register, okay, which all the value we return, all the function we return value, and when it return, it will return in this register, okay, right? So it become a global variable, so to speak. Let's say if we write high-level language like this, then we assign link register a formal parameter x, right? And we need some temporary value to be used in main program, okay? Because we print double 2, okay? So we need some kind of temporary value. We definitely need stack pointer and then return value register. So we define all this, right? And then what we write, we initialize the pointer. We get the value to pass to the function. We push that value to the stack. We call the function. Once it returns, we print the value that is returned, which is returned in a register we call return value. Okay. And the trap number 1 is just to print the value out. And we stop. Okay. Within the subroutine, we just pop the value to our variable x, and then we can add and return that value to return value, okay, and return when it finished. Let's try this out. Boom. We will call it call x. We already have some simple call. Right? So let's call it call x. Okay. And let's run the program. Oops. I don't quite like my MacBook keyboard. Wow, undefined symbol. So we have error somewhere. Well, it is good to show you that how to debug a program. Our program called X, right? Undefined. Oh, running out of time. So I have to wrap this up quickly. Set pointer. Oh, return value. Yeah, I haven't defined the return value. Okay, let's use register term number 27. No. Just save it. Save. Boom. Okay. Assemble. Yeah. And see the result. Look okay. So we run it. Ooh. One by one, we initialize stack pointer, remove temporary value, we push number 2 to the stack, we call the double subroutine, and the subroutine pop that into register number 2. So we pass the value here, okay, and we do the double, and we return at register 27. Okay, so the value here, and we return. So go back and we print that. So number 4 appear at the corner here, and we stop the program. Right. I have to explain this one. So we sort of writing a more meaningful program. So I want to print character A to Z on the screen. I know the coding of character A is 97 and Z is 122. Okay, so I write this kind of program just to use this print character. And the print character is trap number 2. We know trap number 0 is stop. Trap number 1 is to print the integer, and the trap number 2 is to print the character. So this is initialize the character we want to print, and then check if it run to the C, and either if it not yet reach the C, we print it out and increment the code and loop. Okay, we will modify this program to print a string. A string is something like this. Okay, it's some kind of code, blah, 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 and it's variable length, so it terminates by 0. Okay, so instead of just print the A, we need to get this A from a string. String is just the array of character. So we get A from just like getting an element from an array. Okay, so it's become like this. Okay, you get an A, and why the A is not 0, you print it and then increment to the next character, and you get it again and continue. Okay, so this is a program, right? We just get the array by this kind of load index. Okay, and then we write the data section, initialize the string to be at 100. Okay, let's try this program. Boom. Let's save as P string, maybe. Yeah, P string. Not right. Type. Oops. P string text assemble. P string text. Type to C. Look okay. Sim. A bit of rush because the time is running out. Sorry to be like this. Then we can just go and see the result. Boom. So it print A, B, C, D, E, F, right, on the screen, and execute 42 instruction. So that's the end of the showing you how to write assembly language.